let us consider this question. Here the vector space is given by solution of those three equations. Okay, so V is the subspace. So vector space is given by solution of this matrix, that is this equation 1 1 minus 1 and then 1 1 1 2 1 minus 3, and there is another thing W, it is minus 1. Here it was 1 coefficient of x, here it is 0, so 0 1 1 and W coefficient of W is 1. So this was the equations which are given. We have written in matrix form, now denoted by A. If we reduce, so we need to find dimension of the null space. So if we subtract, if we use row reduction, then R3 minus 2 times R1, this will give 1 1 minus 1 0 0 1 1 1, and here it will be 0, then minus 1 minus 3 plus 2 minus 1, and again minus 1 times 0. So now R3 minus R3 plus R1, if we do this, we are getting 1 1 minus 1 0 0 1 1 1, and last row becomes 0. So the rank of this matrix is 2 because there are two non-zero rows in reduced form, and those first two rows contain the pivots. So therefore rank of A equal to 2. So the solution space is given by number of variables. Here number of variables is 4. So dimension of null space or solution space, it is number of variables. Here it is 4 minus rank 2. So there will be two independent, linearly independent solutions. So basis should contain 2 elements. So the answer should be this, because only this contains 2 elements. But let us check that. So if you multiply this with 1 minus 1 0 1, if we multiply this, then clearly 1 times the multiplication, from the multiplication we are getting 1, then minus 1 0, then that is 0 here, then again 0 1 1, so it is also minus 1 plus 1 0, and the last row will be automatically 0. Similarly, multiplying this, if we denote it by the reduced matrix R times this is also 0, right? 1 0 1 minus 1. So those will be the basis of the null space. Okay. Let us solve another question. Here Aij is given by this, the subspace such that 10 by 10 matrices. So there are 100 matrix, 100 entries, but given that even rows are 0, I is even means here it is A1 2, this is I is even means these even rows are 0. A3 1, sorry, this is A1 1 A1 2, okay, and even rows are 0. Okay, so even rows are 0 means we only need to consider odd rows, and there are odd row contains, there are 100 entries, but odd row contains 100 by 250 entries, and all 50 entries are linearly independent because there are no other relations. So clearly dimension of this space is 50. Here Pn is the polynomial basis of polynomial with real coefficient of degree at most n. Now there is a map T which maps Pn to Pn plus 1, that is some kind of integrations and with a mixed derivative. We need to find what is the null space of T. So let X belongs to null space. Okay, that is kernel T. Null space and kernel is same. So this will imply Tx, sorry, the polynomial P. This implies T of Px. This is actually 0. So this means P dash x. Note that here Pn denotes all the polynomials of this form a0 plus a1x up to nx to the power n. Okay, where ai are any real number. So p dash x minus pt dt, this is 0. This is 0 to x. This means p dash x equal to 0 to x pt dt. Now if we put derivative of, suppose this is the polynomial px, if we put the derivative, then it will be a1 plus a2x up to n, so 2a2x n x to the power n minus 1. We are doing derivative, and the right hand side will be integration. So integration is a0x plus a1 x square by 2 up to n x to the power n by an minus 1, it is an minus 1 x to the power n by n plus an x to the power n plus 1 by n plus 1. Now comparing the coefficients, we are getting if we compare the coefficient of constant term, we are getting the left hand side is a1, the right hand side is 0. Now comparing the coefficients of x, it is 2a2 and right hand side is a0. Similarly, if we do all those things, then we'll get in this way 3 a3 will be a1 by 2. It will continue 4a4 will be a2 by 3. In this way it will continue. Now we can note that the odd term will be 0, right? Because a1 is 0, so this a1 is 0 means this term is 0. And again you can see that 5a5 is same as a4 5a5 equal to 5a5. This should be same as, what are the sequence, a1 a2 then a3 by 4, right? Then since a3 is 0, then this is again 0, and in this way all odd terms are 0, all a2i minus 1 are 0, and the last term there is actually, the last term there will be something different, n by n plus 1. We don't know if it is even or odd, but there is nothing for this, so n should be also 0. It does not depend on if n is even or odd. Okay, so n is also 0. A to y minus 1, a odd terms are also 0, and events are given by these relations, that is a2 is a0 by 2. Similarly here a4 is a2 by 12. Now putting the value of a2, we can write a4 as in terms of a0 by something. Okay, so all even terms can be written in terms of a0. So a2 is actually a0 by 2. Similarly a4 is A2 by 12. A2 by 12 means from here it is A0 by 24. In this way we can write everything. Okay, so from here we can see that there will be only a single generator of this, because even and odds are dependent. Okay, and what will be an even terms here? We can see that the even terms will be like this: 2k ak, and right hand side the even terms will be it will be ak minus 2 by k minus 1. So we can write ak, we can express ak as ak minus 2 by 2k times k minus 1 for all k equal to infinity. Okay, so all the entries are generated by those kinds of vectors. So everything is completely determined by what is the value of a0. Okay, all those are completely determined by what is the value of a0. Hence, dimension of the null space will be 1. Right. So consider this problem from GATE 2009. Here, the space is given by, actually it is skew symmetric matrix, that is A transpose is same as minus a. So we know the skew symmetric matrix, the diagonal entries are everything 0, and A1 2, this is same as A1 2. That is, if we flip along the diagonal, it will reverse the sign. Okay, A1 3, and here it will be minus A1 3. It will continue. From there, we can see only those vectors are independent, and any other vectors are completely determined by the upper half part. Now upper half part, there the entries will look like a1 2 up to a1n, then a2 3 up to a2n, and the last non-zero thing will be the n minus 1th position, a n minus 1 and n. So from here we can see that there are only because this is actually the size of this matrix is n square. There are n square many entries. Now if we remove the diagonal entries, because diagonals are zeros, so if we delete this part, then there are n square minus n entries. So the above the diagonal there are n square minus n by 2 entries, right? So from this we can see that the whole matrix is completely determined the upper half entries. Okay, you can write in terms of basis. So dimension of this space should be n square minus n by 2, because upper half has this many entries. This should be the answer. Here I think there is printing mistake for this problem. This will be the answer. Okay. Is it complex vector space? Oh, sorry. No, actually this is fine. We don't need to take 2. Here is the thing. It is given that entries are from C. So A1 to A13, there are 2 choices, and yes. So A12 can be written as, since we are over real number, and A12 is a complex entry, we can write A12 as some real part. Suppose this is the real part, it's denoted by R12, and there is imaginary part. Suppose this is denoted by C. So over real number, those entries are written in terms of those two independent thing again. So it is not actually n square, though there are n square minus n by 2 entries, but since we are doing over real field, so the complex C, this field has dimension 2 actually, because any vector A plus IB can be written as linear combination of those two vectors A plus I times B. So this is not n square minus n by 2, we need to multiply it by 2, because we are doing over real number and those entries not real, those are complex. So there are two choices, one for real part, another for imaginary part. So though there are n square minus n by 2 entries in the upper half, but there are two choices for real and imaginary part. So it will be this time 2, so it is n square minus n. So there are no printing mistakes.